Like and subscribe my channel and share with those guys who want to learn SD-WAN. Thank you so much.
Okay, through this topology, you can understand that what is this actually. So in this topology, you see that it's normal like you that your topology, like we have branches H1, H2, H3. So this topology was created for one of the customer. He is having some hospitals all over the world. So they are migrating to the SD-WAN. So the name is showing H1, H2, H3, and these are the data centers, and these are our controllers. Okay, so in this topology, we have deployed one firewall to use this service chaining feature. How it's work, what is this? I will share with you in this document. So if I will go through this document, in the Viptela solution, the network operator can enable and orchestrate all service chaining from a central controller. Means if you have something in your environment like ITP, firewall, any load balancer, and you want that one site when will able to communicate to another site, that should be go via that firewall. So that kind of service you can introduce in your SD-WAN fabric, and through the central controller, means from the vManage or vSmart, you can control that one. No configuration or provisioning is required at any of the edge router. It will just like a policy. So the general flow of service chaining with Viptela network is as follows. vEdge router advertise the service available in their branch or campus such as firewall, IDS and IDP to the vSmart controller in their domain. Whatever the service we have in available on the SD-WAN fabric, so that service will be advertised on the SD-WAN fabric so that other edges will know that okay, if I want to use this service, I need to reach that branch. Multiple vEdge router can advertise the same services. vEdge router also advertise their OMP routes and TLOCs to the vSmart controller. Okay, so for traffic that requires service, policy on the vSmart controller change the next hop basically. Suppose one site want to reach to another site, so it next hop will be the tunnel endpoint IP, the IPsec tunnel endpoint IP of another edge. Correct? That's how it can reach. But if you are introducing any service in your SD-WAN fabric and you want that site 1 will be able to talk to site 2, but before that its traffic will be filtered through the one firewall. If they are using internet, so just a double security, customer want that okay, I don't rely on the internet, I want that this tunnel traffic should also be filtered and should also be monitored through the firewall, then this site will be able to talk to site 2. So that's what all the things is written in this document. vEdge router also advertise their OMP routes and TLOC route to vSmart controller. For traffic that requires service, policy on vSmart controller change the next hop for the OMP routes to the service landing point. In this way, the traffic is first processed by the service before routed to its final destination. The following figure, if you will see the same here, local site 1 want to communicate to local site 2. So if we forget about this service, then what will happen? This site will be able to communicate to VS2 through the IPsec tunnel directly through the BFD session they already have. But if we want that if this site will be try to reach to site 2, but before that it will go to the firewall. So the traffic flow will look like this. It will go to the firewall and through the firewall it will reach to the VS2. That's how you can make secure your environment, right? If you not rely. So the same thing is written here. The network shown has centralized vEdge hub router that is connected to two branch each with a vEdge router. The standard network design implement a control policy such that all traffic from branch site A to branch site 2 travels through the vEdge hub router. Sitting behind the hub router is firewall device. So now assume we want all traffic from site A to site 2 to be first processed by firewall. Traffic from vEdge router at site A still follows the vEdge hub router, but instead of sending it directly to site 2, the hub router redirects the traffic to the firewall device. When firewall completes its processing, it returns all clear traffic to hub, when which then passes to along vEdge router at site 2. So that's what it is we are doing here. it will communicate to site 2, but first it will reach to the hub where we have deployed the firewall, or you can deploy this firewall nearby any region, nearby any site, anywhere else, and the same service you can advertise for multiple location. Only the policy you need to create, and that's how you will be able to change the next hop for this site if this site want to reach to another site. So that's how it will work. So there is some predefined thing done by the Cisco Viptela. The hub and local branch VH router advertise the service available in their network to the vSmart controller in its domain using service route. So those routes are called service routes, which are sent via OMP using the service route subsequent address family identifier SAFI bit of the OMP NLRI. The vSmart controller maintain the service router in the RIB, and they don't propagate these routers to the edge. So there is something fixed like VPN ID, we know service ID identify the service being advertised by service node. So basically we will configure one VPN ID, a service ID, and some service ID is fixed, like for firewall it is 1, for IDS it is 2, for IDP it is 3, and others are also available like net service 1, 2, 3, 4, which are reserved you can use for the custom services. Label for traffic that must traverse a service. The vSmart replaces the label in the OMP route with the service label in order to direct the traffic to that service. Right? Basically, it's tagged one label so that your next hop will be changed. Originator ID, the IP address of service node that is advertised to the service. TLOC we already know, transport location address of edge that is hosting the services. Path ID and identifier of the OMP path. I think somebody asked the question that time, what is path ID? So that is an identifier of the OMP path. How you will create that policy? Simply you will go to the policy, add policy. Some prerequisites we already completed like site list name, VPN, prefixes. So whatever is required to make this policy, we will define that one. Define site list, add site ID, VPN, right? We have defined this site ID already here, H1, DC2, DC1, DC2, H1. VPN list we defined already, VPN 10, right? Now simply we click on next. Now we will add a topology and follow this custom control route and TLOC. So basically we are changing the next hop here. So you will find that option under this. So in the topology we will change, because we are not changing any routing, we are changing the topology now. We are asking to edge 1, if you want to reach to edge 2, first you need to reach to the hub. So basically we are changing the topology. So on this one we will click on route. Under the route, first rule, first you will mark that site where you want. In our topology we want that H1 will communicate to H2 but with the help of firewall. So first we will mark our site H1. Okay. Then H1 accept, action accept. Under the accept we will map that service, net service 1. Which VPN? We will define the VPN. Okay, that is a part of VPN 10. If VPN 10 want to communicate to VPN 10 to site 2 from site 1, then it will use that service. So we can map the service here, net service 1, and that's it. We will save it, and the same thing we will do for the H2. If H2 want to communicate to H1, then it will also follow the firewall. So only two rules we need to make. First we select, let me repeat it again. For add policy, simply custom control route. Under the route, first rule, for the first rule we will map the site, action accept, and then we will map, and the action accept we will map the net service and VPN. That's it. The same thing we will do for H2. So here you can see we have two rules now. For H1, action accept this service VPN 10, H2 net service to VPN 2. Okay. So this is the policy we will create. So we were using that time a firewall, but maybe it's not detecting, so we use the net service too, custom things. And and that is a one another thing, inbound site list or outbound site list. Today I will share with you that what is the difference between inbound and outbound, right? So here we have defined this policy for the outbound. Then we map this site. I will show you the difference, that what is the difference, why we map this in outbound. Okay, and then we activate it, and that's how that you can see the flows. I think yesterday we have seen how you can see the flow on the trace route. So we have seen the flow. This site is reaching to this. This is the status just before apply the policy. Okay, and this is the status after apply the policy. Now it is detecting another hops. This is the edge devices and firewall IPs. 5050.1, 50.5.5.6. If I will show you the topology here, so you can see the first packet is reaching here on this hub, then it's going via firewall and it's coming out. So these IP it is detecting. So that now from this trace route we are able to know that okay, that is following the firewall path. So that's how you can introduce any service and you can use that services. And through the trace route, you can easily check that my path is correctly following. So this is the destination IP of another site. So we put the destination IP, same VPN 10 and checked. Okay, hope has been increased. Now first traffic, even if we will go to the check to the show OMP session, or then you will see that next hop will be the change automatically to reach those subnet. Their subnet will be show to you that these are subnet belongs to site 2, but next hop will be the change, means the TLOC IP will be the change. Okay, so now let me share with you how this outbound and
Like and subscribe my channel and share with those guys who want to learn SD-WAN. Thank you so much.